Hello everyone, this is Meghana from Bay Pharmacy. Yes, steroids and triterpenoids. We are studying about triterpenoids. You know triterpenoids, you have heard, you have seen in the syllabus copy, but you don't know what it is. Yes, it is a secondary plant metabolites, that's why we are studying it. But what is triterpenoids? Before going to it, I'll introduce the one more person, that is one more chemical unit of the triterpenoid, that is isoprene. Isoprene is the unit, or else triterpenoids are derived from isoprene. So triterpenoids are also called as isoprenoids. Okay, like terpenoids, not tri. It is a classification of terpenoids or isoprenoids. Terpenoids, in the sense, they are derived from the isoprene, as I said. We have the classification of terpenoids, that is monoterpene, diterpene, hemiterpene, di over, triterpene, tetraterpene, terpenoid, not terpene, terpenoid. Then we have sesqui terpenoids, SESQUI terpenoids, SESQUI terpenoid alkaloids. Sorry, lactose, or else lactone. Yeah, lactone. Okay. So we get all the secondary metabolites which we are studying in third unit, which is very much important for the basic introduction before going to it. So we need to know how it is synthesized and their classification already I said. But monoterpenes, as I have seen, that is we have menthol and citral. Many are there other examples, but menthol and citral, we will see how it is derived. Okay, they have not given. Saponin means glucone part. Even we have saponin, triterpenoid saponin, they will say. In saponin is the triterpenoid. Okay. The extraction procedure for triterpenes. Okay, there is a common extraction procedure, so we can remember this one. If we know that, like citral and menthol, they're all monoterpenoids, so kind of terpenoids, but it's only for triterpenoids. So examples for triterpenoids we need to find. Triterpenoid is glyceritinic acid, only one we have, that's all. So it's waste so to see, because in triterpenoid we have Lieberman test. Yeah, we have seen in glyceritinic acid. It's waste to study here, because already we are going to study in glyceritinic acid. That's why I'm not explaining here, but still we need the terpenoids. What are terpenoids? Isoprenoids. Isoprene is a 5 carbon structure. I will just show you. See, I wanted to just show this thing. See, this is the isoprene, you can see in the thing. That is what hemiterpenoid is. Like, it is a basic unit of terpenoid. So that's how, I don't know how they are synthesized, but based on the polymerization, like isoprene forms the terpenoids. But how they differentiate each other, I don't know. Like monoterpene, diterpene, how they differentiate, I don't know. If you know that thing, if you get that thing, then you will get how to write the structure. And for remembering also, you can remember, cholesterol. If you wanted to just remember the cholesterol structure, you know that it is a triterpenoid, you will get how to remember why it is having this many rings, what is it means. Then you will definitely remember and write in your exams. I googled that how terpenoids are derived from isoprene, that's how, right? So that's why I asked likewise, but they didn't answer me in the correct way. Yeah, terpenes. See, monoterpene, sesquiterpene, diterpene, triterpene, tetraterpene, polyterpenes. How we got menthol? I want to know that things. See. Okay, let's watch the video.
Hello everyone, you are welcome back to my science class channel. Today is the second lecture in the study of lipid biochemistry. With the first lecture we talked about lipids.
Okay, let's see that they are explaining that they are having some characteristics of triterpenes are the natural products that are structurally related to isoprene. Isoprene means 2-methyl-1,3-butadiene. Example of terpenes in plants and animals. We know the example already: menthol, citral, where it is, why, how it is, why they are used, where they are used, everything we know it.
Of lipids. talked about other derived lipids. They are structurally related to.
You can even see what are the importance in the plants and animals. B carotene is gives the color for the carrot, which is in this color, right? Yeah. Lycopene promotes squalene and immediate in steroid synthesis. Intermediate. Limonene gives the color to the citrus fruit. Glibi Gibberellic acid, growth hormone in the plants. Yeah, gibberellins, we know that. Carotenoids, light absorbing pigment in the plants. So in plants also they play a role, and even in animals, like if they eat them, they're also having the physiological properties. Then coming for classification, terpenes are classified according to the number of isoprene units. Okay. Terpenoids means what? Isoprene derivative, terpenoid. So how many isoprene are there? So it's classified based on that. There can be cyclic, open chain, double bonded, other groups in it. So we have cyclic triterpenoids, also cyclic phenols, cyclic alcohol. So it is citral is the best example for the cyclic one. Open chain means citral. They can, okay, all terpenes are constructed by head to tail. Okay. Example, head, tail, isoprene. Okay. See, we have monoterpene, that is citral, they have given. Sesquiterpene, I would like to give, that is artemisinin. Diterpene, I don't have any example in our syllabus. Triterpene, we have glyceretinic acid. Tetra, we don't have any tetra, I guess. In future, we may get. Polyterpene, I have not heard this, but that's rubber. Plastic, I don't know. Polyvinyl, I guess. Polyvinyl chloride, that's the thing. Okay, let's see, like monoterpenes will be having, isoprene will be like 2. Then you can guess that they are, I am expecting that how the chemically, structurally, how they are formed. I want that, but I'm not getting it. Monoterpenes. Sesquiterpene is having 3. Diterpene is having 4. Like mono is 1. It's not 1. It's 1 into 2. Like we are counting isoprene here, not terpenoids. So terpenoid is 1. Maybe like you imagine that terpenoid is made of 2 isoprene. So that's why monoterpenoid is 2 isoprene units. Okay. So likewise, sesquiterpene is 3, diterpene is 4, triterpene is 6, polyterpene is 8. Okay, I was expecting this thing, right? Okay, we have 2 isoprene units here. They are just connected, as they said, it is connected like head to toe. So that is how they form. That's all. There's nothing much big chemical reaction in it. It's just a polymerization reaction. It will be joining. But I don't know how the cyclic means interactions, intramolecular interactions will be there. Not inter, it's intramolecular. So then the compound is formed. Yes, that is how. That's all. So we know that what are the monoterpenes. Even citral is also, citral is a monoterpene, we know it. Means it will be having 2 isoprene. We can see in the structure, that is 2 isoprenes are there. Like 1 isoprene, 2 isoprene with the side functional groups. Like CHO is not the part of isoprene. So that's, they are in that part. So we have functional groups. So likewise you can remember. But I don't know how glyceretinic acid is a triterpenoid. Like we need to know how cyclic terpenoids are formed. So from that we will get how glyceretinic acid, that is a triterpenoid, how it is formed. Okay, we have that glucuronic acid is in the side chain, which is attached to like a ether bond. Ether something bridge they'll call. Yes, glucuronic acid. Like it is having a 2 glucose compound, like glucose or something carbohydrate. I guess it is a glucose only. Yes, it is glucose. 2 glucose compound is attached with 1 bridge. Again, I'm talking about that bridge. So likewise it is glucuronic acid, and this glucuronic acid is connected to the triterpenoid structure with the bridge, that ether bridge. Yeah, I think it's not the bridge or something, but when the O is connected, like oxygen is connected, then they'll say that is the bridge. I would like to show that. Let's see whether in
Said we
this
have
video we have
four
it or
carbons.
not.
If I see from here, we have one.
How to identify isoprene units? Yeah, yeah. Let's see this, how to identify.
Okay. So as I said earlier, as you can see from here, we have 1, 2, 3, 4. So we count 1, 2, 3, 4, and take note in the characteristics of terpenes. We said they can have double bonds, they can have single bonds, they can be cyclic. So don't be confused that.
Why it is important? Because see, they'll ask the structure to write. So the reason why they are asking the structure is we need to know the basic first to memorize the structure, to remember the structure. We can't just simply memorize likewise. So that's why we will get to know what are the things, why are these things. So in the name of this thing we will learn this fundamentals. So that's why they have kept. It's nice, it's not that much difficult anything. It's just isoprene means triterpenoids, sorry, isoprene, terpenoids. Then many things are there, like classification, you know it, and you know the structure, and you know how it is formed, and how to identify isoprene units. Okay, isoprene, like see the ending of the chain, you can just see 2 double bonds will be there. In the isoprene we have 2 double bonds and 5 carbons we have. Count from the double bonds till the double bond end, that's all. So that's what you need to do. Let's see what they'll say.
This is not having a double bond, but the normal isoprene unit is having a double bond. There can be a double bond, there can also be the absence of double bond. So take note. So
Okay,
just have to count from the part closer to the metal end. So as you can see here, you have the metal group here. So you can start counting from 1, 2, 3, 4. Then
One sub
one,
branch
two,
will be
three,
have
four,
only
then you
CH3
must make
from
sure
the
that
second
the head is closer
carbon.
to the metal group.
So
as you can also see from here,
from
1,
there
2.
you can count.
That means there is this metal group over here. So the metal group should be carbon 5. So 1, 2, 3, 4. Then you cut the next one. 1, 2, 3, 4. But make sure that the one is closer to the metal
Free
group.
chain will be having the double bonds, and the ring one, which will be like a ring cyclic form, so that they don't need any double bond. The valency won't satisfy if you put a double bond over there. So it does not require any double bonds there. So that's why it is eliminated. So how to count there in that case? So you know that we have a side chain, that is CH3 group, which is attached to the second carbon, that is in the isoprene I'm talking about. There we have, so you can just count from the side chain, like they have number right from 1 there, from there you can count 1, 2, 3, 4. Yeah, then one isoprene is done, and another isoprene we have the side chain. We will get the side chain, the CH3 group which is attached. So there, from there you can count 1, 2, 3, 4, and the fifth one is the last one, that is the side chain. So likewise you can, like, 2 isoprene forms a cyclic one. Oh, I was expecting this thing, I got it. Okay, it's easy, it's not it's rocket science or something. Okay, I think it's enough.
Then you cut 1, half, 2, 3, 4. This is one is it's closer to the metal group. So that's how we identify.
And we have some cases we have dotted lines
rewind the
also.
video and make sure you get the understanding very well.
Like, you don't
So
worry
let's
if
try
it is
this.
like dotted lines, they are like behind the structure. So that's why it is in the dotted lines, which are in the bold lines, which are front. So that's why it is bold in, that's why it's highlighted. Okay, but it is a bond, that's all. You don't think that it is slightly bonded, it can be removed likewise. No, not like that. It is a bonded, like covalent bond. So covalent bond is a very strong bond than ionic bond. It's like that. Okay, I think we can remember these things, where what comes, we can remember. Artemisinin structure is very quite complex. It is a sequence terpenoid. As we said, that sequence terpenoid is a 3 terpenoids only we will be having, right? Like 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1 2 3 है 1 2 3 4 5. So likewise, if you mark this 3 isoprene thing, then you will get 5 5 5 5. Yeah, the second carbon will be attached with the CH3, right? So this is the first one, 2 3 4, and this is 5, and this is 5, this is 2, this is 1, this is 3, this is 4, that is 5, and this is 2, this is 5, this is 3 4, this is 1 2 3 4 5. So we have like that, and the side rings are like these two are joined. Okay, this is the only thing you have to remember. This is joined, and we have O group. In the easy form, if you expect me to write like without any bold lines or else the dotted lines or something like that, if you expect me to write like that, I'll write it. See, here we have, but here also they have one ring over there. See, oh, it's not first one. Oh, but it is still, it's the first one. Artemisinin. This one is attached to this one. Yes, I got you here. Artemisinin, this is the structure. Okay, I would like to show by writing these things. Yeah, I will show here. You can see this is 1, this is 1, this is 2, this is 2, this is 3, this is 4, and this is 5. Here, okay, we should leave this structure, this line we have to leave it. Okay, we have to start from here. 1, this is 2, this is 3, this is 4, and this is 5. And I think you can just remember these things, this side things, all right? Yeah, but here we have this thing, a carboxyl group and this bridge, a carboxyl group and this bridge. Okay, this first carbon of isoprene is like CH3, right? Like we will be having CH2 double bond CH3 CH double bond CH, oh my god, CH2, right? This is what isoprene is. Here what is happening is they are removing one hydrogen, like, yeah, 2 hydrogens they are removing, and they are replacing it with, I'll just write it once again, they are replacing with oxygen, and again, so that's why, and again one more bond is coming over here, and we have oxygen. This is the bridge which I just talked about. So that's why in order to maintain the valency, it will, one double bond will go away. So now carbon is having 4 valency. So this is how they have done. I think you can remember now this whole thing. Now let's move to this part over here. So we have this CH3. This is the 5th one, and this is the 2nd one, and the first one is, I don't know where the first one is, 3rd, 4th and 5th. First one is completely done with oxygen, right? But still we didn't cover these things, right? This one, as I said, this is 1 2, this carbon is done, 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 this carbon is done. Yeah, that is done, but this carbon which it's not done. Okay, you just think that it is the extra branched one. Okay, like it is having like a carbon and one oxygen, here one oxygen, But for this I said like it is having the oxygen bond over there, and this oxygen is connected with, already it is connected with one carbon, and that carbon is connected with one hydrogen and one oxygen, which is not the part of triterpene. I will just change the color. Okay, so this is not the part of isoprene, but it is a functional group kind of thing, like COC, what it can be. Like carbon double bond is also not there, one hydrogen and another one, 1 2 3 4, yeah, but it's a single oxygen, but we have two oxygens which is connected like this. It's not the case. It's not carbon double bond O, it's carbon 2 oxygen. I don't know what it is called, what I should call them as. It's not ether also, it's not the case. Okay, this carbon which is having, it's connecting the another one triterpene. It's connecting two terpene groups, right? This one and this one it is connecting. So okay. But we didn't get one carbon here, right? For this isoprene, we didn't get first carbon. First carbon is here, okay? That is also having like a OO, which is connecting this one. Like artemisinin is like three isoprene units. That's why they are sesqui. Here you can see sesquilactone. Like lactone they have mentioned, right? We don't know what sesquilactone looks like. Let's have a glance. Yes, here where I got lactone, sesquilactone. Terpenoids are simple. See, you can just see here. This is very much simple. But sesquiterpene lactones are with lactones are complex. Yeah, you can see here. It's quite easy, right? I think you can write artemisinin structure. If they ask, you can easily write it. As I have explained many details, you can just write. We have 3 isoprene, as I said. Okay, so you can just remember this structure. We have 3 isoprene. Okay, this one is connected to this one as well as this one. Okay, 1 2 3, 2 is connected to 1, and this is also connected to 3. Likewise it is there. Okay, I think you can write. Only other than isoprene is this one and this bridge, 3 kinds of bridge we have. Okay, this bridge is connecting with 2 is connecting with 1. Okay, and this bridge which is like this one I'm talking about, and this one is like why it's not going. I don't want it to just exaggerate. You can just remember only these 3 things are the extra things. This carbon and this oxygen, which is the bridge kind, acting like a bridge. Okay, this CHOO and this one, this is the thing only you have to remember. I think once if you write without seeing, it would be more better. Take your time and write without saying. Yeah, I tried it out, but I can just remember the details, but I couldn't write. So that's why practice is much more required than like it is also required. Both the things are required. Okay, let's write once with seeing, and then we'll try it out without seeing. First, we will write this structure, and then we'll write this structure, and then we'll write this structure. Okay. Like we can write this as like a benzene, and we can write oxygen here like this, and then we can write the side structure and on oxygen like there, and we can write one hydrogen over here and one oxygen over there, right? Like a benzene, like hexane you have. Likewise you can write here one O, here we have H, here we have O again, and we have oxygen, and here we have CH3, and we have like this another one, we have CH, and you can just complete, just simply you can write, after writing this one you can just complete it like a puzzle, and then we can write the CH3 group there, and again there comes our third ring, that is like how much, 1 2 3 4 4 deviations kind, where it ultimately meets with the oxygen, and we have this thing and this thing, and it looks like a goggles over here, so you can just remember like that. You write 2 times, and without seeing you can write ultimately. Okay, if you want, like you have to mention hydrogens, because in case of benzene we used to not mention, because it's understood that the valency is satisfied by hydrogens, but here we need to write. So there are 3 hydrogens over here, so we'll write the hydrogens like that. All, like if you want the detailing structure like this bold lines, the CH3 and H, the CH3 and H groups are all in bold structure. Okay, yeah, you can just write in the bold structure, it will looks very much detailing. Okay, then I think we can write without seeing. First the benzene, like a hexane one, and 2 kind of oxygens, and we have another one oxygen, and again we are having one more. Okay, just above that oxygen, this here, the next thing we have hydrogen and oxygen. Okay, firstly we will write this benzene hexane type, the hexane type we will write, and we'll have this oxygen, and then we have that again one oxygen, above it we'll write hydrogen, and again the oxygen, and we have other thing we just shouldn't forget, CH3 group. Yes, CH3, next to the CH3 itself we have hydrogen everywhere. Yeah, like you can see here, you have in this carbon it is satisfied 1 2 3 4, here also 1 2 3, only 3, and even that will also be having one hydrogen, right? Okay, if you don't wanted to write hydrogen, it's simply understood that it is having hydrogen. Okay, you don't need to remember the hydrogens, because you see here in this carbon we have only 3, but there is no hydrogen mentioned there. You can just say like H, and next carbon we have satisfied, here also we are not satisfying, only 2, we will be having 2 hydrogens over there, so we can write like that. So it's much more complex, the structure looks. Okay, we'll complete anyhow. 1 2 3 4, then CH3, and the goggles, and the hydrogen. If you want you can write, I would not prefer writing hydrogens, because we can write wherever the hydrogen we want. Okay, let us write without seeing once again, it will be a very good practice. Okay, let's see who will write the first. Hey, everywhere artemisinin structure is visible, I should hide it. I will hide it and I'll write. Actually, I couldn't try this thing. It was again the bad idea because I couldn't able to write the third one. Like I remembered everything, but I couldn't draw the line perfectly like that. So firstly, we'll write this structure first. Hmm. First, we'll write that O, Mr. O, and then we will write this. And oh my god, yeah, I'm writing. Mm, yes, I just remembered everything which I want to write. But I didn't join them, I just separated them. Okay, just extend it to the way long. We'll just extend it. It looks like a kind of geometry. Then here we have that CH3. Yes, I am done. And then the goggles. Don't miss that goggles, okay? Hey, I can write. This much of practice is not required. It's easy. Just by looking the structure, we'll be able to write. Okay, let's move on to the other structures. Okay, we have citral. Hey, move. Why are you not moving? We have menthol also. First, we'll go for menthol. We'll see how many. Yeah, as I said, it is a monoterpene. Monoterpene will be having 2 isoprene. So the side structure. So then this is 2, this is 5. And the first one is obviously next to it. Yeah, let's say this one. Yeah, obviously that one. And 3, and this is 4. We are left with 1, 2, 3, 4. And this is obviously, this is second one. And this is first one, this is fifth one, this is third one, hey, this is third one, this is fourth one. Yes, if you want me in detail, I'll just say it. See, this is our first isoprene structure, and the second one is the rest. This is 2, this is 1, this is 3, this is 4, this is 5, this is 1, sorry, this is 1, this is 2, 3, 4, 5. Yeah, then this is the only menthol. So all OH. That's all. I think you can write without seeing in minutes. Write it in minutes. Menthol, its name. It's 2 isoprene units are there. Okay. The first one is like a benzene structure, CH3 and this OH, and we have takadimita. Then that have the kalu. I think it won't work as far because if while writing I'll just remember the detail like, oh, it's having 2 isoprenes and 1 hydroxyl group, but I don't know how to write them and how to join them. So it's better to memorize the whole structure, how to write them. Okay, I think you wrote menthol. We'll move to citral. Citral is also the same, that is also having citral, monoterpene, right? Yeah, monoterpene. This is the 2, 1, 3, 4, and this is 5. And we have, this is done. This is one structure and that is one structure. This is 2, this is 5, this is 1, this is 3, this is 4. And we have only aldehyde group. But here it is not joined like this. If you join it, we'll get menthol. But we even don't have hydroxyl group. So this is citral. So that's why here we can see it's a aldehyde group. Monoterpene aldehyde. I was wondering why, how can I remember these things? I can just remember now. Okay, firstly you just write a half hexane. It is 1, 2, 3, 4, 5. Okay, 1, 2. Okay, then you write like this. You write extra things. Explaining is easy, but the thing is memorization, and ultimately have to go and write in examination. Okay, you can't experiment whether if you are writing, you can write it or not. You have to memorize it. How can we memorize? We'll divide the structure. Mm, Half half. Okay, how you will memorize this one? Yeah, you will write half half. Like in menthol we wrote like this, and we wrote the leg to it, and the side structure, like here it was, here we'll write here in this case. Okay, but we will write like this first, and we'll write the leg for it, and 1 2 thorns. Okay, we'll write half the structure and leg for it, and here we have CH3, CH3, here we have CH3, 1 2 3 4 5. The second, in this isoprene we have 2 double bonds, right? As I said, the first one will be having double bond, so the first one will be having the double bond here. Okay, and that's all. Wherever you'll find the side chain, you'll start numbering over there, right? From like if you find like here, you'll just say this is 5 and this is 2, and the 2 beside 2 you will just say this is 1. After 1, no, then this is not, this is 1, this is 5 or this is 1, which one is correct? This is obviously 2, but which one is 5, which one is 1? Obviously this one should be 1, not 5, because soon after you write first one, soon after you write the first one, you have to see the double bond. So soon after you write the first one, you will write the double bond over there. Hey, hey. Not to think much more, it's triterpene 1, triterpene 2, triterpene, that's all. Go. Not triterpene, isoprene. Okay, we just wrote, it's like a 5. You can remember like that also, or else it's just a half and the leg and the thorns for the head. That's all. I think citral is done. Then artemisinin is also done. Now coming for glyceretinic acid. This is triterpenoid. Triterpenoid is like 3 into 2, that is 6. So 6 triterpenoid. This is separate. This is glucuronic acid. This is the bridge I was talking in this video. So here we have to find where is the things we have. See, you remember that menthol structure, right? We have like this, we have one OH group. That is how the menthol structure is there. We don't have any double bonds in it. This OH group should come here. Okay, like that. Okay, I think you don't need to find any isoprenes here. You just know it is 6 isoprene units are there. You don't need to find anything. You need to memorize the structure, right? So just write this two things and the ultimate one thing. Here we have 2 legs, like this. Okay, firstly we'll write this thing like this. Okay, we'll write these 2 things and these 2 things and this thing, and we'll write this thing, and we'll write this one is mandatory. This is what it's connecting, right? Yes. Then we have I think it's very easy. It's not complex. See, glucose structure, this structure, okay, this H is replaced with this connection, okay. So you can write this structure here. This only thing is you should write this structure. I think you should do some tricks to remember. They'll ask caffeine this, yeah, those things they'll ask. Structure. I don't know why. Yeah. I'll just check which are the structures they are asking for the exams. Like in 4th unit also we have reserpine. Reserpine is there, caffeine is also there, quinine also there, atropine is also there. Yeah, they'll ask in this unit itself. This is routine. Routine is not terpenoid. It's a glycoside flavonoid. So one will be glycon part and other one will be a glycon part. See, they have just said it. So you have to remember like that. Glucose part is not there. It's a flavonoid glycoside. You should know that flavonoid glycosides and all. How it does. It won't help you. It will just say why the structure is like this. Okay. But it won't help you to memorize it. But ultimately, if you forget everything, like if you don't know anything, you will remember the terpenes, isoprins, everything. So there you will remember, oh, this is the thing, citral is the thing like this it is, and menthol is like that, and artemisinin is also like this. Something you can write instead of leaving empty. You can write, like memorize just by remembering all those informations about the structure. But I can't give you the information for this atropine. See how atropine is like those chair boat pathway that is there, right? Like that it is. So how can I create a story? Like all the groups are having OH, and this is the change, and you have this oxygen also. Next to it is oxygen. You can remember this thing, this right part. If you want to remember this one, you know that what is it? Resocinol. Yeah, resocinol. And this one, what is it? I'll get you. Okay, I was wrong. Resocinol is this thing. It is having a gap. No gap means catechol. Okay, let's write without seeing. That is routine. It is a flavonoid glycoside thing. Let's write. Where to write? No space. Okay, we have that one benzene. Hey, we didn't write glyceritinic acid. Okay, we are proceeding, right? We have okay, I just wrote. It's very easy. People can also write. Don't forget the bonds. And don't forget those OH groups. I think we can write once again if you want. I will write it once again. I won't see anything. I didn't look also. OH, 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 OH. We have CH3 also, and another O. We have this EIO. I am done. Oh, I just forgot that thing. Okay, this is routine. For one kind of information, how many messages we should? Okay, done. Then we'll move to atropine. I have written them in one jagger. It's fine. And here, don't write like this. Okay, I did the same mistake. It should be like this and this and like this. Why? Because it is like maybe it is CH something, CH, and again it will be bonded like this. Here maybe one carbon, here in this jagger maybe one carbon is there. Okay, we'll move to atropine. And one thing I like to say, morning I was just writing these structures, but I found an easy structure for artemisinin in Google, but I don't think it is the correct one. So write the right one. Okay, don't Google it, don't believe it, just believe the textbooks. Okay, let's see the atropine. Atropine is like one phenol group, which is again connected like this. How can we remember this one? And this thing is very much complex. How can a person can remember this one? Like it is like a butterfly. And NCH3. What is it? Okay, atropine is tropane alkaloid. It's an alkaloid. That's why it's having a nitrogen in it. I'll just, yes, I got here. Like this is the easiest structure. Why we need to remember those butterflies and all? We can just remember this thing. I don't think so this is the correct one. It's just one. Yeah, it is in medicinal chemistry. If we won't believe this one, we can just go there and see. PubChem, don't lie. Okay, I will go with this one. No, I'll go with this one. See, it is a 7-membered ring. 1, 2, 3, 4, 5, 6, 7. 7-membered ring. In that we have one nitrogen, and that nitrogen is connected with methyl group. That methyl then it is connected with COO. We had this in our medicinal chemistry. Yes. CH2OH. I'm getting something here, some logic I'm getting. Okay, coming back to this PDF of atropine. Like we have the 7 bonded ring, right? Yeah. One is like nitrogen CH3 and one will be like O. And the other like COO. I'll just split. Yeah, here we get a very beautiful wave comparing both the things. Yeah, and we have CH here. In this we have CH, OH, and C double bond O, and here we have the ring, right? Okay, CH, and the next side itself we have the ring. This CH will carry like 1 2 3 4. Then why it is CH CH2 OH? Okay, it's not directly connected to the ring. Hey, come on, we'll just exit this thing. See, for this one we are doing the thing. We have carbon double bond. Okay, I'll write down only double bond O, and we have another one CH, and we have OH, and we have a propane ring. Right? Am I right? Yes, I am right. We have oxygen, and we have that 6-membered, not 7-membered. Yeah, this is a propane. Why the people will give the wrong information like this? See, it is not having any CH2OH group sidewise. It's just OH. It's not CH2OH. It's just OH. A propane. See, here also we will. Oh my god, everywhere it is the same thing. But why in this thing it's just a one line? They are representing it is like this. But it's just like this. Which is correct? This one or this one? I'll believe PubCam. Yeah, this is PubCam. See, they are showing. Then the textbook is wrong then. Yes, the textbook is wrong in the structure. They are missing one CH2 group. A propane everywhere. Oh my god. Like, see here. I would like to write this thing itself. See, it's like a structure. It's very much beautiful. It's like a sketch. There is something called here. We'll say why it is like that. Yeah, levo-dextrose. Something is going on. See, that's why they have marked in the way. Atropine is a tropine alkaloid and anticholinergic medication used to treat the certain types of nerve agent, poisoning, as well as in some type of slow heart rate, and decrease the saliva production during surgery. Typically given to intravenous injection to the muscle. Eye drops are also available to treat the why it is given, I don't know. For eye drops it is given. Yeah, I know it. Myopia or glaucoma. To reduce the intraocular pressure it is given. Intravenous, in which category the intraocular pressure is high? Sorry, what's that? Okay, I don't know why. Oh my god, I think we should take a break. I think atropine is done. We should see glyceritinic acid. From there it is all done. Try to write glyceritinic acid. Write those things. And doggy don't like my doggy understood my mind voice. Just shut its mouth. Oh ho, there is some essay in this. Hi. Dance with my hands. Like Jesus say. I wrote with saying. I would like to write without saying. I wrote very horrible structure. Cheap. I want a new space. Let's write two dabbas and let's try to connect those two dabbas with the one and the other. Okay. And we should remember where and all the OH or COH is present. We have OH, 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 OH. Pami, get up, it's 10:30. Pami, get up, it's 10:30. I would like to write once again. It's very nice, so that's why I would like to write it once again. This is connected to this one, this is OH, this is OH, this is COH, and this is OH, this is OH, and this is Pami, get up, it's 10:30. Have your dinner and go to bed. Yeah, I am done. Yeah, I got lyserotenic acid, everything I got. We have completed menthol, citral, artemisinin, glycerotenic acid, routine, atropine. We have learned 6 structures. We are left with 1, 2, 3, 4, 5 structures. That's all. Those are, I guess, it's easy, I guess. Yeah, quinine is a kind of, what is that, pyrrole, right? Yeah, I'll just check what it is. It is also a kind of alkaloid. Like same like atropine. It's an alkaloid, but not to the structure. Structure-wise, it's different. We have, what is it called, this one? What this is called as? I'll just check it. What is pyrrole attached to? Yes, not pyrrole. What is called? A pyrrole is attached to a benzene. Oh, it's a indole. Okay, this is a indole. Okay, so indole is having a side chain, and that is connected to again this CH 1, 2, 3, 4. Yeah, CH. This thing we have to remember. First time seeing this quinidine structure, I was wondering what is this. It is like a CH2 double bond. This bond is like a bold one, so that's why they are made it like this. Okay, and we have this one. It's easy like this, and it's like zigzag and N, and this thing is connected to this thing, like just like this. One is OH. That's all. I think we can write without saying it. Okay, firstly we have indole structure. We can write that indole structure, and we have that zigzag N, and here in this OH. It's very much easy. Yeah, we can write it. Quinine. Okay, I'll write without saying. Firstly, our indole structure, we have that all, and it is joined to the zigzag thing. This, oh sorry, here OH, and we have H. That's all. We are done. Okay, quinidine is also done. Reserpine will come. Oh my god. Reserpine is a sarpagandha. It's a alkaloid. So pine, quinine, atropine, atropine, quinine, reserpine, all are alkaloids. Okay, they'll ask this structure. They have asked this structure for 2 marks. How can we remember this? Okay, let's divide the thing. This one and this one. Like you know that benzene is connected to the pyrrole. Oh, that one is indole. Okay, this is indole. Yeah, this is indole. Benzene with Piperidine. Oh, this is isoquinol. Okay, okay. That was quinoline. Okay, I was a mistake. Sorry, sorry, sorry. So that's why it is quinine. Quinoline, you know, right? Quinoline. Yeah, quinoline. So that's why quinine. In because it's a alkaloid. Okay, it's a alkaloid. That's why it is having something like this. It's a quinoline. It's not isoquinoline also. It's a quinoline. Okay. Then we have this structure over like there. This is in. I think you can just remember these things. Quinine already we wrote. We are here in Josephine. The lesser point we have one indole structure over here. We have what is this called? Esters. CH3, CH3, CH3. Yeah. Ether group. Ether group we have. And we have consecutive structure. So this thing and this lastly this thing. Okay. How can we remember? I think you can remember this one and this one. These two things are quite complex, right? So we will see. Like this one we will draw. Yeah. And we'll write N over there. And rest of the things are H, H, H. The other thing is here. Hmm. Mommy. The last one is completely OOO. Apa bantu? Apa bantu? Hmm. Oh, I don't want to do